In this video, we're going to learn how to test paired data in JMP. So in this example, we're asking whether taking breaks improves employee productivity. A company was investigating the use of mandatory short breaks throughout the workday on its employees. They have a random sample of 20 employees, and their productivity was measured on a day without breaks and then measured again on a day when breaks were mandatory. It doesn't say this, but you would want to randomize the order of those things so that you didn't have an order effect. And we want to know, was the average productivity of these employees higher with breaks than without breaks? So we're looking at two variables here. One is their productivity, right? That's the outcome that we're interested in. And the other is whether or not they're taking breaks. So that's a categorical explanatory variable. So to decide which type of analysis to do, let's think about the structure of our data. So here we have 20 employees and each of them is being measured twice, right? So we have paired data because we have each employee's measurement with breaks and without breaks. What would the advantage of this paired design be? So we're taking two measurements per person, and that's a way to get around the fact that some people are just going to be more productive than others, right? We don't expect everybody's baseline productivity to be the same, but taking two measurements per person allows us to compare each person to themselves. So it's easier to see an effect if you're not having to look at it overall, but you're able to just compare each person to themselves under the other condition. So comparing each person to themselves makes it easier to see the effect, which gives us stronger evidence. So that's the big advantage of a paired design. It's not always practical. Like if you think about like medical treatments, you can't really try two treatments because if the first one works, then the issue is gone and you can't treat it again. So it's not always practical to do a paired design, but if you can, it's advantageous because it tends to give you stronger evidence. And knowing that the data is paired also affects the way we state our hypotheses. So instead of writing these as two separate groups, we're going to write this in terms of the differences. So we're just going to look at the mean of the differences. And let's go ahead and define here the order that we're going to subtract in. Let's do breaks minus no breaks. So that's how we'll define our subtraction. And I want to go ahead and do that now because that's going to affect whether we use greater than or less than signs. So of course the null hypothesis is just that the mean of the differences is equal to 0, right? That breaks don't have an effect. The alternative hypothesis here is going to be that the average productivity of these employees was higher with breaks than without. So that means that breaks minus no breaks would be a positive number. And the question asked, does the company have sufficient evidence to conclude that mandatory short breaks improve productivity? So the process we're going to go through is we're going to create a column of differences, and then we're going to use analyze distribution to analyze that one column. And there's more details for this on the reference sheet. Before I start in JMP, if you want to follow along with me, I made a tiny URL for this. It's tinyurl.com/3000-productivity. So first of all, notice how the structure of this data set is different. Instead of having only one numerical value per case, here each employee has two different numbers. They have their breaks number and their no breaks number. And we're interested for each individual person, which one was higher and by how much. So we're going to create a column of differences by clicking Columns, New Columns up here. And then we'll give it a name. Let's just call it Differences. Then I'm going to click Column Properties and choose Edit Formula because I want to come up with a formula for the differences. And I define differences as breaks minus no breaks. So I'm going to just click breaks, the minus sign up here, and no breaks. And then click OK. And I can see now that it's working, right? If I do breaks minus no breaks for this first employee, I get -3, and so on. And the last instruction for a paired t-test just says to analyze that column of differences with a one sample t-test. So we're going to go back on the reference sheet up to the instructions for a one sample t-test. So for that, we click Analyze Distribution, and we're looking at the differences here, so we put that in the Y box. Since we're looking at the differences, the categorical variable has already been taken into account, so we don't need to put anything in the buy box. We just click OK. And I like to look at this horizontally, so I'm going to click the arrow next to distributions and choose stack. And from here, it's just like a one sample t-test. So I can click the arrow next to differences and do test mean. The hypothesized mean is 0. That's my null hypothesis. I don't have to change anything in that second box. I just click OK. And I can see the information about my t-test is given here. If I wanted to do a confidence interval, I could do that too. Next to differences, I can go down and pick confidence interval, and then I can get different confidence levels. So let's say I wanted 90% confidence. I could click that, and this gives me the lower and upper values in the confidence interval for the mean. So this is a quantitative response, so we're using a t-statistic. And it tells us that our test statistic here is 2.0244. For the p-value, we have to choose the one that's appropriate based on our alternative. So notice the one with the absolute value signs, that would be used for a two-sided test. But we just have a greater than sign in our alternative, and so we're going to pick 0.0286 as our p-value. 0.0286. And it tells us that our alpha level is 0.05, so this p-value is less than the alpha level. When the p-value is less than the alpha level, we say that we have sufficient evidence to draw our conclusion. So in this case, that would be sufficient evidence to conclude. Remember, we're always trying to conclude the alternative. So in this case, the alternative would be that breaks improve productivity. And if we were to use the confidence interval, that would give us an estimate of how much breaks improve productivity.